Old and Trey. I don't know.
Sam, you want to?
I don't know.
Oh, you do a good job of keeping it.
He's so annoying.
He's my partner wrestling.
He reminds me of the cousin that I hate the most.
What?
He reminds me of my cousin that I hate the most.
Yeah, I guess you're playing that.
Yeah, we did actually. Yep. Yeah, we played it with like 10 other people. Not even 10.
Yeah, really?
Yeah.
Legit? One
Yeah.
catch? 100%?
Yeah, when
And
me
he's
and
already
Garrett
said
planned
Esther,
our
Luke,
Jordans.
Joel. It's kind of stupid.
Not like one of the cool kids who's never in an orange Monster shirt.
I just filled with snow this morning.
Mine was covered in.
Why are you caressing each other's shoes?
I'm just keeping my foot there.
He's like petting your shoe.
You guys have matchy shoes.
Yeah. Send mine over. Sure, you're gonna go.
Sure.
Right now.
What's money? You literally go like this when you wear it.
Becca, there was a kid with a finger thing yesterday. Thought of
Yeah.
you because like she had a
I actually jammed my finger yesterday too, but it's good. It doesn't like didn't pop out place.
It was one of those where the kid went to show his coaches. Coach was like, so it was like all like bent. Like she said it was really bad. Yeah.
Well, he probably did it down here. Mine was way here.
Yeah, his it was like at the first joint, I think. But,
That sucks.
yeah,
Couldn't be me.
I don't know. He went back in. I said Becca would have gone back in.
Yeah, I'm sad. I would have.
Did you see? Have you ever seen the
If it was
video of
close
Kobe
games
when he like dislocates his finger and then like goes to the trainer, gets it popped back in, and just walks back out?
No, I have to look that up. It's awesome.
Like he's like when she's putting it back, and then he's just like, alright, thanks, and he walks away. And
No,
then, like
no,
drops
I've
like
seen that.
40 points.
All right, so we're going to talk a little bit, seems like a weird warm-up question, kind of is a little bit weird, but what we're talking about today is kind of, like we talked about this a little bit yesterday in terms of a secant line. Today we're going to talk about like a tangent line of a curve, and now a tangent line is where a secant line hits twice, a tangent line only hits once. And what we do is at that tangent line, we find the slope at that spot, and that's what it's called, defining the derivative. So the word derivative is kind of a new word for us today, and that's something we use a ton in calculus. So finding derivatives is kind of like the basics of calculus, kind of like you're adding in, basic math. Derivatives are kind of the basic idea with calculus. So we're getting into that here today. Now the equation of the slope, talking about the slope, that rate of change is kind of the important supporting role for this. So hopefully you guys remember to find slope, just do rise over run, and we look at our b value. So what's our equation of our line here? What'd you guys get?
-1/2 x plus 3.
Yeah. So it crosses the y-axis at 3, and then our slope is down 1 over 2. Very good. So finding that equation, that line, probably not as necessary as what we're going to be doing today, but thinking about the idea of that line, that tangent line that hits the graph at that point. And we'll be talking a lot about the slope there, or more about the slope. So this is this new formula, this difference quotient we had showed yesterday. I'm going to show you guys a new version of it today. And again, this is a little bit better version. And it's not really all that different. It's just rather than using the delta t, they use an h. And so really it's not crazy better, but it's still slightly better here. So this instantaneous rate of change, what that means is if I'm talking about a situation, let's say we're throwing a ball into the air, and I want to know the speed of the ball at one particular spot, what that we're finding there is that derivative at that point, and that's called the instantaneous rate of change. So if your car is accelerating, what's you know, the speed at like the point before you hit the ditch or whatever it happens to be, or, you know, like before you decide to hit your brakes. So, now we're going to use a symbol we haven't used for a while, and that's that limit symbol. Actually, let me.
I didn't like
Is that the one with the infinity?
that. Yeah.
Yeah, we're not using infinity on that. Now we're going to talk about when h approaches 0.
Does H still like equal X or whatever? Like this center.
No, good question. So he asked about h being, is this like the center of the graph like our h and k? No, this is a new h. Welcome to new h. Sorry, I know. Why wouldn't they pick a new variable? I don't know. I don't know even why they chose h here, so I don't have a good reason for that. But hopefully you notice this formula is really similar to the one we learned yesterday. Instead of h, it was like delta t there. But they use t's for so they had t and delta t. This is kind of trying to help you with that a little bit, where f of x is like the starting point, and then f of x plus h is the next point. So it's kind of that change still. So it starts at f of x, and then it goes to f of x plus h. So h is still our change. So that m, it's the slope of the tangent line at one particular point. So it's the slope
Don't worry, take your
things.
time. You're in no rush.
So we're going to use a symbol for derivative. Just trying to remember what I was going to write here. So the derivative, we say f, and it looks like a little like apostrophe kind of, f prime of x. I guess maybe make it a little curvy. That's called the derivative. And this all goes together. So when we're working with this, that's going to give us this derivative. So we're going to use that symbol here today. So it says find the derivative of the function at the given point. Now this one, they kind of give us the values already. So we're trying to find f prime of x here. And they're giving us the x, and they're giving us like the f of x. Sorry, I almost lost my notes. What was I doing here? So we're going to use that big formula up on the top, as this is my x and this is my f of x. So we're trying to use this value. So they're actually giving us, if you put -2 into this function, they've actually given you the value as 8. So if you put -2 in, it's -2 to the -2 to the second is 4, 4 times -2, wait, that doesn't work. Hang on, sorry. Give me a break here for a second. Let me try to find what I need.